This video is presented by AmazingPhysicsForAll.com. Do you know what is a supernova in astronomy? Supernova is an explosive, violent death of a very massive star. Just to give the etymology of the word supernova, nova is from the Latin word novus, which means new, unusual, or extraordinary. In 1572, the Danish astronomer Tycho Brahe used the term nova stella, meaning new star, when he noticed a bright new star, as bright as Venus, suddenly appearing in the constellation Cassiopeia and then slowly fading away. So, the word nova refers to a newly appearing star with sudden increase in brightness for a few days and then slowly fading away. Astronomers initially thought that the event must be located far away from other stars. And, therefore, this phenomenon was named supernova. Now, let us explore what supernovae are, how they occur, and what are their types. First, let us quickly review the evolution of stars and understand how stars evolve over time, and then see in what conditions supernovae occur. Then we will discuss the types of supernovae. The diagram here shows how stars evolve from birth to death depending on their mass. Chandrasekhar limit is the mass threshold of a star which determines their life cycle paths and their end stage of their lives. Astrophysicist Chandrasekhar discovered in 1930s that stars with mass less than 1.44 m, where m is the mass of our Sun, would end its life as white dwarf. And stars with masses greater than 1.44 m would take a different path to annihilation. For instance, Sun-like stars end their lives as white dwarfs and eventually as black dwarfs. Whereas massive stars, after supernova explosion, end up as neutron stars or black holes depending on their masses. Our Sun, which is currently in the main sequence stage, has been burning hydrogen in the core for the last 4.6 billion years, producing helium as a leftover. But when it runs out of hydrogen in 4 to 5 billion years, it will start burning helium in the core, producing carbon and oxygen. Because our Sun's mass is below the Chandra limit, when all the helium in the core is used up, the Sun will become a red giant first and then will turn into a white dwarf. The death of stars like our Sun will be silent and peaceful. However, the end story of massive stars is completely different, most violent. Now, let us explore what happens in the case of a very massive star. Massive stars, with masses 8 m, where m is the mass of our Sun, or more, unlike Sun-like stars, are able to take the nucleosynthesis process beyond carbon and oxygen. Such massive stars can continue synthesizing elements up to iron in the core. Even these massive stars cannot continue the nucleosynthesis beyond iron because iron's nucleus is, not only, very stable but also requires tremendous energy to fuse two iron nuclei. So, iron is the dead end for all these massive stars. As fusion stops in the iron core of a massive star, there is no outward radiation pressure from the core to counter the crushing gravitational force of the outer layers of a very massive star. At this point, the gravitational force triumphs, and it literally crushes the iron core of this massive star into its constituent atomic particles. The solid iron core disintegrates into electrons, protons, and neutrons. The electrons in the core, zipping around at the speed of light, start the neutronization process. Electrons get pushed into protons to create neutrons. Now the entire core turns into a neutron star, consisting of only neutrons, releasing a burst of neutrinos. The core becomes a huge nucleus with no empty space in it. At this stage, it is impossible to compress the core any further. What happens next is more dramatic. As the matter in the core reaches nuclear density, a teaspoon of neutron star material weighs about 1 billion tons. The size of the core becomes very tiny. Therefore, the core implodes in 1/4 of a second. As the core suddenly collapses, the outer envelope too falls onto the core's surface at the speed of 40,000 kilometers per second. But the falling outer envelope encounters a hard wall, and it is stopped dead on the surface of the core. This creates such a massive shockwave that it results in a violent and most spectacular explosion. This is Type II supernova. During the supernova explosion, a star with mass of 25 m could eject 24 m of its mass as gas clouds and leaves the rest, 1 m, in form of the neutron star. The ejected gas clouds can span several light years across. For example, The Cassiopeia supernova A remnant, shown in the picture, is 29 light-years across and it is about 11,000 light-years away from the Earth. This is remnant of a massive star that exploded about 300 years ago. The well-known star in the Orion constellation is Betelgeuse. Its mass is almost 20 times the solar mass. Currently, it is in red supergiant stage and almost at the end of its nuclear fusion cycles. It can go supernova any time in the next 100,000 years. When it goes supernova, it will be so bright that it will be visible even during the daytime, though it is 600 light-years away from us. Now let us look into the types of supernovae. Astronomers classify supernovae into two broad types, Type 1 and Type 2. Type 1 supernova is an explosion of a white dwarf, whereas Type 2 supernova is a violent explosion and death of a massive star at the end of its life cycle. This table provides a quick view of the two major types of supernovae. Please subscribe and give a thumbs up if you like this video. If you would like to read more on similar topics, please visit amazingphysicsforall.com. Thanks for watching.